Hello everyone and welcome back to Kanayi's AI Lab. In this video, we will see how Claude AI helps building end-to-end projects, starting from data preparation, image training or any data training, and final building an application. So this is going to be a perfect video those who wanted to learn and practice AI model building without any coding experience. Now let's start with the video. So this is an example of an image detection or object detection. The object is helmet in this case. Each and every frame, the object is identified whether object present or not, and what is the bounding box. It's a Cartesian coordinating system giving the location of the object present in the image. Also you can see a number represent, that's a confidence score of every prediction within the video. So we are going to build this project in the real time. So normally a computer vision expert would take to build this kind of a project maybe another 3 to 4 days. Sometimes it will be more than that based upon the complexity of the problem and complexity of the activity. But with the Claude AI, this can be reduced approximately into 30 minutes problem. May not be on an ended scale production system, but this entire model can be built in 30 minutes of time. So what a surprise it is, right? So we can see how this is possible. This is possible by using automating the entire activity within the Claude, including the data preparation and project setting, model training, Flask deployment, browser-based inference, etc. etc. But one thing you need to remember, Claude doesn't have any internal GPU-based training setup. So you need to train your data, custom training, need your local system, or you can use any cloud-based GPU setup. Now, similar to any other AI model, so we need input data set. In this case, the data set is nothing but images as well as the corresponding annotations. The annotation normally in the Excel format, and it's very mandatory for the training part. If you look at the folder structure, you can see two folders where we have images in one shot and another one is annotation. Images, we have around 760 for images present. Each and everything is represented giving a name 0, 1, 2, 3, etc. And this will be with helmet or without helmet. And when you look at the other one, we have one more thing called annotation, which is nothing but in the XML format. It's talking about what is all about this image. If you see what is the image name on present in this particular, this is the 0th image, and this is talking about what is the size of the image in terms of width and height, and it's giving the class either it can be 0, that's represent with the helmet, and 1 is without helmet. And once the class is defined, what is the input we are giving? It is the bounding box of the object present in the image. This is how we are giving the training data to the model. So let us understand this data description. Now the second part is very essential to build a Claude project. We need to have a detailed and very smart prompt. If you see, we have a prompt which is well labeled and well written. It consists of objectives, details, and model training requirement. All these parameters, whatever it is required to build a complete end-to-end project. And if you see my prompt, which is nothing but starting with my objectives, and also it has something talking about the constraint, and it is all the information about what is the workflow, what is the technology, what is the coding guidelines, what are the required files after completing the project. Also we are mentioning about what kind of UI UX is required. So we are preparing a Flask based project in this case. So testing will also be done inside, and finally we need these output. Maybe if you see, this can be a little lengthy, and same time this much is required to get a complete project. We don't want to stuck anywhere. But you can remember one thing, the better your prompt, the better your result. That's simple logic on Claude projects. Now, the Claude can be launched by using claude.ai, and you can use either web-based application or you can use the desktop application with the proper credentials. And there are multiple versions. Enterprise versions are available with more features, and we have a small setup of free version with limited credentials and limited facilities. So we are building this entire problem by using the free versions. Now I am moving to my Claude web-based settings. So here is the Claude app where I did some pre-settings. What exactly the pre-setting means? When you open a claude.ai, you may not be able to see this kind of a setup. So you need to go to your project folder, So there is something called project is available. So you click onto this project and you are going to give some information. So information is all about what is your project name and give some detail about the project name. Then click on the create a project. Once you click the create a project, there will be a setup like this. What exactly we are doing, I'm again given my prompt in the pre version only. So I given all the prompt here, end-to-end prompt, whatever I mentioned in the last time. Also my data for the training, including the image and the annotation, it's already given to the Claude. It is uploaded here because it's almost 500 MB. It will take a lot of time to re-upload again. So this is the setup for me. So I'm just going to click this arrow mark to start executing the process within the Claude. Now you can see here the process started. So maybe it will take some time for some activity depend upon that. So it starts the activity with unzipping the data set. As you see, actually there are two images which is zipped only. Now Claude is unzipping it and checking what is exactly inside, how many number of images, what are the different folders, what are the different classes, and whether we have all the classes for all the annotation presents or not. Everything is checking in detail. So data checking completed. You can see check here data annotation completed and check the data structure completed. Now we are running one by one. Maybe some complicated activity here, some time will take. So it's checking the file name. File name is completed, and we have XML annotation that is also completed. Now we have got a response say the data set is in a good condition where this many number of images are there, this many annotations are there, and these are the two classes available, and there are XML files have available in this case. Everything about the data. Now after data inspection, it is moving for different files. So it's configuring the config.py file, which is basically a Python format file. The configurate file setting everything in one place, such as folder path, training location, and other configuration values, etc. This makes the project easier to manage and update. This is what this config.py, which will be available to keep everything in one place. Now after config.py, we are expecting some another file like convert.xml.py. This is nothing but, when you see our folder structure, this is basically an XML file. But when we are running a problem like an object detection, so the data annotation should be compatible to the YOLO format. So the YOLO format, normally we say that YAML format. This conversion, each and every image and corresponding annotation is converting into this convert_xml.py for the YOLO compatible format. So this is happened in this particular phase. Now the conversion happened properly. Now see what is exactly happening. It's happening the train.py, which is the core file. So the train.py used to train the YOLO V8 model using our internal data set. It prepares the data, starts training, and finally saves the trained model. YOLO is nothing but you look only once, which is the best algorithm for detecting the objects. Next, it is predict.py. Predict.py is between the Flask app. It's exactly responsible for running the inference using the trained model. It loads the saved model and predict helmets on any new images or any new videos, whatever we are going to give it. So predict.py is happening. After that, the another important one, app.py. App.py is the Flask application that connects the AI model with the web interface. It accepts the uploaded videos, then runs the detection and displays the output in the browser. Of course, when you have app.py, we are expecting a neat and clean web pages. So we need to have some kind of index pages. We need to have some CSS format. So these main web pages that user interact with, it provides an interface to upload the video and view the detection result. And same time, the CSS file will give the clean and modern appearances. It controls the color, it controls the layout, spacing, and the file. Overall, we are getting a good look and feel. Might be multiple bootstrap will be there and taking the best one. So this is what happening in the UI side. So it's updating app.py in this case, and it's producing the result. Let's wait for the further activity. We are moving to the almost end of this particular problem. So let's wait for getting the proper responses from the Claude. As I mentioned, sometime when it is running a lengthy activity or complicated process, so the result will generate some time. So now the CSS, the core of the visual identity, completed. So styling is almost done. So we may expect a good index page for the best user faces. So we have a new file now. That's what requirement.txt file. It lists all the Python library required for the projects. So maybe running the pip install function required for installing all the necessary libraries, maybe within everything like an automatical setup. Also, we have something called readme in this case. Readme is again another combined setup of instructions. It also helps to install, how to install like a readable document, and how to train the model, and how to run the application, etc., etc. So we have complete information now. So now it's testing on a synthetic video using the predict.py function, and that mimics the helmet detector interface. The processing of testing is happening in the backend. So once the testing is happened, we are expecting some kind of result in this case. So excellent, all the test is passed and test result is already stored in the interface. Now all the flash routes tested working, all the error handling path working properly. We are getting proper information. Now it's building a collab notebook. So why collab notebook? So as I mentioned, Claude doesn't have any training setup with GPU inside it. So that's why we also generate a Google Colab notebook. We particularly mentioned on the prompt, which needed to train the model for free using Colab GPU. So we don't need to write any code. So we just take the code and we just run the code and get the final output. That's a trained model output from this particular Google Colab. Or you can run with the local, but definitely this kind of a problem required a lot of libraries which may be complicated with the CPUs, or you need to have a GPU in the local system. So we are getting the Colab notebook. Again, the Colab notebook will generate trained model. So best trained model with best weights and available. You will have a last trained model also. So normally we use the best trained model weights to perform the app on the applications. So it's validating one by one. So everything is present. Now it's completed. Final re-verification of conversion pipeline. Everything is working. Very good. Now let's wait to get the complete packages in the zip format like app.py, train.py, predict1, conversion, configuration, requirement text, readme. Everything is available. Then it is packaging on the zip file. So creating one by one, starting with the train.py, then app.py, then creating the final project in the zip format. That's actually our major requirement. So we can able to download the entire zip format. After downloading it, we will be unzipping it and keeping the entire document on a Google Drive like this. So here you see that. So this is the version of the last run of the same Claude, and I have everything in place. You can see here, this is by using the config.py. Everything is available within the drive. So let's see how it is created on the Claude. Let's see here whether we are able to get it. Yeah, you can see here. So this application, you can use it, helmet detection proj. You can download completely. So this download will go to the download folder. From this download folder, you can see what is available inside. So it's downloading. Yeah, the download completed. Once the download completed, you can see the folder structure. It's having data sets and it's having models. And all this py file, readme file, requirement file, and this is the file which we are going to run on the Colab, right? So we are going to run this particular file on the Colab. Let's move to the Google Colab. So this is the Google Colab folder. Google Colab folder, we have a IPYNB notebook type of file is there, which we are going to run it separately. So don't worry, this code is already available. You are just need to connect the drops, right? So we are starting with our confirmation whether we have a GPU. Yeah, we have a GPU of NVIDIA, and we are taking the dependencies of installation, like we need Ultralytics, we need OpenCV, we need PyAML, everything is done. Then we upload the projects. Once upload the project, we can see the data set. Also in between, we are mounting the drive to connect our Colab with the drive. So passing the data set which is available on this drive, and we can see that this many number of data set is available and this many number of annotation. Once the data set, again this convert XML py will convert the XML py into, or XML file into YAML file, which is compatible to the YOLO problem. And here is the major steps happening, training the model. You can see here we have 50 epochs are available, and 50 epoch is completed. With every epoch took almost 10 seconds. So that's what I already run this file before, so that I can avoid the complication of time issues, right? So all these 50 epoch completed, this product, it's actually classified with the different classes, and we have a good result also. You can see this is the precision, accuracy. Basically, these are the performance of the model. So after this, what you are going to get it, maybe you can download this. What exactly it is, you are going to get a trained model. We are going to say that the trained model is best.pt. So this trained model is shipping it now. Now I'm going to open it. So when you open this particular folder, you can see there is a file called best.pt and last.pt. So what happening exactly, after training this particular model, YOLO V8 creates a file called best.pt and last.pt. Best.pt is the file contained trained AI model and is one of the used to helmet detection, because this is going to be the best model weight for you. And this one, normally we don't use it because this is the last model weight. Sometimes last model weight may not be correct with the best accuracy. So that's why we have a best.pt. What exactly we need to do, this best.pt from here we need to cut and we need to put it in the proper formatting where we need to keep it. So take the best.pt from here, and after that we need to paste it on the folder structure. I can guide you to the folder structure where it is. Again, helmet detection projects. Here there is a folder called model. Here in this folder you need to keep your best.pt. So that's what we need to do. So this is what we are going to happen now. So assume that this is completed because I have already kept this everything, right? Now what we are going to do, we are going to launch our command prompt and see the result, whether it is working properly or not. So I am just taking the directory path. Directory path has everything, and I'm just taking a command prompt on this system by using the command prompt. I can see that this is actually user admin, but my project is available in the different folder. I'm just passing the directory which is available in D folder. This is the path of the entire project. Now what is happening? So we can see here on this particular collab final notebook, so the everything is available. You can run the python app.py to get the model in the browser. So we are going to get the Flask API and everything, indexing is everything is available. Now we can run this Python file. The file of the Python is app, which is in the py format. Once you are done with this, you can see this file is running now. So this file will display a local URL, usually something like HTTP format. You need to copy this address into your browser where you can upload the video, and you can see detecting the helmets, which almost happens within time. So it's running now. Let's wait for that. So just wanted to copy the HTTP address and you need to paste it onto the new browser, right? And maybe a sample you can see here. So this is the one which we created, and I'm just checking whether the URL is available and URL is ready. Now it's taking time. Let's wait for that. Yeah, now you can see here, this is my URL. I'm just copying it from here and pasting onto my new tab. Let's see whether we will get the browser output or not. And once this browser is available, what you are going to do, we are going to upload an MP4 file. So to get the final inference, we need to upload an MP4 file. This is a video analytics problem. So I'm just clicking here to get the file. As you see in the presentation time, I have a data which is a new video file which predicted something, right? How it predicted? We are going to give a test data which doesn't have any prediction, and just uploading this test data here. So selected test and which run the detection now. So this detection will take another 10 to 15 second time. So what exactly is going to happen after detection? You will get a video like this. Again, you will get a final result in this particular format. Let's see how it is predicting. I'm going to check the file. So in this particular folder, I can see test with the result. Maybe if you see here, It will take another 10 second or 15 second time. We don't want to waste our time. So this will be able to download it after processing. You can able to download it. So this is the already downloaded file which is given as a test with the result. I'm going to play this video for your inferencing. You can see the video is going to load now. Okay, what is happening? So there is a person with a bike and our object mentioned is the helmet because the data is very clear and the problem is here. This is a real-time object detection problem to detect the object which is helmet in this case, which predicted very correctly with what is the object and what is the bounding was and where it is present and what is the confidence score on each and every prediction. This is all about the simple problem on object detection. But what is the beauty? Everything is created by the Claude project feature. So no code written in between. If there is any code, we don't need to write any code. It just execute the code. So in this video, we learned by how Claude project can generate complicated AI problem into very simple project structure and training the script on Flask web application with just well-written prompt, saving hours of development time. Thanks for watching. If you enjoyed the video, stay tuned for more AI content with Kanayi's AI Lab. Thank you once again.